Okay, so when we're talking about classes, this is now classes and therefore objects. Objects are generated from classes in Python. We'll take a look at, this is just a very introductory level, what a class is in Python. We'll talk about methods inside a class, data inside a class, the init method, which is construction of an object, and then we'll briefly talk about inheritance. Okay, so what is the point of a class? Well, a class is, suppose you wanted to make a piece of storage, but it's not common like an integer or a float or a boolean or a string. It's not something common, it's something odd that you're making for your application. So suppose, for example, if we went on Facebook, and when you log into Facebook, it asks you what's your first name, your last name, date of birth, what's your gender, I forget what else it asks you, right? So Facebook has one way to define a person. You go on LinkedIn, they define a person a different way. And that first name, last name, email, password. But they might want to know your resume or where you worked. So they have, every application defines a person a different way. So we wouldn't want to have a programming language like Python define a definition of a person. It depends on your application. What you're doing with a person determines what you think a person is. So just to get the point across and keep it simple, I'm going to define a person as someone with a first name, a last name, and a year of birth. Year of birth, the year they were born, not the day, the month, just the year. This is my, silly definition of a person. First name, last name, year of birth. Okay. If I want to start making a lot of objects, a lot of pieces of storage of persons, I define this to my Python environment, and then I can make persons over and over, just like you can make integers over and over. Okay. And I could set up these default values if I want. Okay. Now suppose that was, so I make a classification. So I say class, person, semicolon. Then I indent, and I have the variable first, last, and year of birth, and I can even assign some values to it. Okay, so now, suppose I come along and I want to start making variables of the type person. So I could say variable p1 equals a person. So what I'm effectively doing is I'm calling the function that creates a person. So I can say p1.firstname is Joe, p1.last name, that's the subfield, last name is DiMaggio, p1's year of birth, 1914. And I could do that. I could create a different person. p2 is a person. So I allocate a piece of storage that can contain the information about a person, and I assign the reference p2 to refer to it. And then I could say p2's first field is Mickey, p2's last field is Manuel. If I then printed out their first name and what year they were born, first name, last name, and the year they were born, this would say Joe DiMaggio was born in 1914. And Mickey Mantle was born in not available. Not available? Yeah, not available. So I supplied default values. You could come along and change them later, but if you don't, I throw in some defaults for you. So what is a person? A person is something I don't want Python to supply the definition for me. It's something I'm going to make up. If I make it up, it's a class, a classification. Okay, now, you know how when you use a primitive type, that's a type of storage that Python supplies for you, like an integer or a float or a boolean or a string, you can say x equals 10. Creates a variable called x, and you initialize its value to 10. You can only initialize it to one thing because it's one field. Suppose I wanted to create a person, and I wanted to say, I want you to initialize the values, but it has a number of values. It has a first name, last name, and a year of birth. I want to supply the first name, the last name, and the year of birth, and I would like you to initialize it for me. So unlike a variable like x that only just takes on one value, I'm now going to supply a lot of values for you to initialize it when you first create this object. So the question is, we need a function, but now we're going to use the word method. If a function is inside of a class, we're going to call it a method. We're going to need a method that only runs one time when you first create the object and then can never run again. And the purpose is to initialize the fields. So in where are we? No, sorry. Okay. So, so now the sorry, where we were here. Okay, sorry, I was a little out of order there. Okay, so in the predecessors to Python, C++ and Java, they have a method they call a constructor method. It's the method that gets called the one time you create the object. And in those languages, they always name the method the same name as the class. In Python, we call it underscore underscore init underscore underscore, and then it takes in a list of parameters if you want them to take in parameters. Okay. All classes have a function called underscore underscore init underscore underscore with parameters, which is always executed when the class is being initiated. Okay. So, for example, in my class, I would say class, person, first name, give a default value, last name, give a default value, year of birth, give a default value, and then I would supply not a function, a method, and I would define the method underscore underscore init underscore underscore, and I pass in parameters. And always inside methods, which are inside a class, is actually a reference to the object we are now creating. So we create a piece of storage, and then we have a reference to that storage so we can always refer to it to fill in fields. So the first parameter is self. That's the parameter to the piece of storage we're in the process of creating. And then I can pass in the first name, the last name, and the year of birth. And then I can say the first field is equal to the F parameter, the last field is equal to the L parameter, the year of birth is equal to the Y parameter. So I'm initializing the values. Using self is optional because if you use internal variables, it assumes it was for the object being created. I could have said self dot first, but I don't need to. So when I say P1 equals person, this would now be an error because I'm requiring 3 parameters. This first one is optional, but the next 3 after are required. Okay. Okay, so you must supply parameters to the init function if the init function is written with anything more than self. Self is by definition the piece of storage being created. We make a reference called self and we point at it so we can refer to it. But any other parameters that you put after it, if you do not give default values, they are required. So for example, we could say P1 equals person Joe, comma, DiMaggio, comma, 1914. It would be Joe DiMaggio, 1914. We'd write them onto the fields and we'd be all set. If you then came along and said, I'd like to make a second person called Mickey Mantle, but you don't give a year of birth, the year of birth, Y, is an input parameter that is required and you didn't supply it, therefore you get an error. You can't create a person if you don't give them a year of birth. Okay, all right, good. Member functions. So what's in red, I'm just adding to this class. So I can make a class, and I can have an init function, initializes the first, the last, and the year of birth. I can add other methods like get the year of birth and return. It will return the value of the year of birth for that object. And I can say set the year of birth. You give me a year of birth and I'll set it to that field. So see, I made a mistake. I call them member functions, right? They're actually member methods. If a function is inside of a class, we call it a method. If it's outside of a class, like the area of a circle, we call it a function. Okay. All right. So why did this work without the init function? Why does this work? Why would this work? I didn't supply an init function. The init function is the function that runs every time we create a new person. So you would think it should be required, but it's not. I could have 3 fields, no init function, and I could set them myself to default values, or just not set them, and Python will set them to whatever the default values are for fields, but we don't know what the fields are. Are they integers, floats, or whatever? We don't know what they are, so Python wouldn't know how to set them. But this is actually legal Python. It looks strange, but I could say P1 equals person, and it will create a first name, a last name, and a year of birth, and initialize these values. This is exactly equivalent to this. So what we can do, if you remember when we were talking about functions, you can have a function and have its body be passed, meaning it's a function that does nothing. So I can have a first name, a last name, and a year of birth, and then an init function that doesn't do anything. And then I could create a person. So it looks odd, but this is actually legitimate Python code. Okay. Like I said, this is a very high level. That we're going to talk about inheritance in very big detail in another lecture. But while we're talking about classes, classes is where you define chunks of storage that are odd for your application that we would not expect Python to supply for us. It's stuff we're making up, like the definition of a person. What you could do is you could have a class like a baseball player, and you might think, well, isn't every baseball player a person? There's no dog baseball players or cat baseball players. So, if we're going to define a person as having a first name and a last name and a year of birth, isn't really a baseball player, doesn't a baseball player have every attribute that a person has, but in addition to that, they have attributes that only baseball players have. A baseball player is a special kind of a person. And so, so instead of redefining everything that is inside of a person and then adding new things for baseball players, suppose someone came along later and redefined, suppose inside of our application we added a new attribute for a person, which is like, what is your middle name? Well, then we'd have to change it in person, and we'd have to also remember to change it in baseball player. Wouldn't it be nice if we changed person, baseball player would automatically pick up the new changes? So back in the 1980s, when C++ came out, they came up with the idea of inheritance. So inheritance is effectively, we have a class called person. It has a first name, a last name, and a year of birth, and an init function when we create one. And then we have a class called baseball player. But in baseball player, inside the class, we put in the parentheses, in the bracket, in the parentheses, we put in person. Meaning, a baseball player has every attribute that a person has, and then in addition to that, it has more stuff. And the more stuff is batting average, right? So this is, I'm obviously doing a very small example here. I'm just trying to get a point across. I'm defining a baseball player as a person who has a batting average. That's it. All right. So I have an init function here. If I ever go to create a baseball player, the first thing that I'm going to do is I'm going to create the person, the first name, the last name, and the year of birth, because that's what a person is. And then after that, I'm going to set that batting average. So If I have a class called person, which has a first name, a last name, and a year of birth, and an init function which will fill in the storage when I first create a person, then I make another class called baseball player, which inherits from person, meaning every baseball player is a person with more stuff. The more stuff is the batting average. So when I go to create a baseball player, the first thing I'm going to do is I'm going to get a chunk of storage that has all that person information. I'm going to call the init function and fill that in. Then I'm going to have my own init function fill in that batting average. So I can make a variable called BBP, baseball player. That's a variable. And I'm going to say it's equal to a baseball player, and I'm going to put as my input Joe DiMaggio, 1914 Yankees, and batting average. Oh no, I have a team, right? I have a team. Okay. So your default batting average is 0, but I don't have a default team for you. I don't have a mechanism to say, I don't know what team you're on, so you're on the Mets. I'm not going to do that. So there's no default team, but there is a default batting average. Try to create somebody without a batting average, I'm putting in 0, and you can fix it later. So I can create a baseball player called Joe DiMaggio, 1914 Yankees, 325 batting average. That was DiMaggio's lifetime batting average, if you've heard of Joe DiMaggio. All right. So when this init function runs, we have a first name, a last, we have parameters, and the parameters are the self, the object that we're creating, and then all the input parameters that came into this method, not a function method because it's inside a class. First name, last name, year of birth, team, batting average. So the first thing I do is I call the init function of the person, passing in the first name, the last name, and the year of birth. I pass those in, and those get filled in. Then I come back here and I say the team is whatever the team parameter is. So Yankees, their team would be Yankees. And the batting average, the BA, whatever came in as my batting average, I would set that to the batting average field. So this is how I would initialize a baseball player, Joe DiMaggio, who was on the Yankees and has a 325 batting average. Joe DiMaggio and year of birth are fields in the person part of the class. Yankees and 325 are in the baseball player part of the class. And baseball players inherit from persons. So really, I've just made a baseball player which inherited attributes from a person. Okay, so now you might think, what is the point of methods? What is the point of these methods? If anybody can just come in and change Joe DiMaggio, I can make him, the Babe DiMaggio, right? And Babe Ruth, right? So what's the point of this? So, so we have public attributes. Okay, by default in Python, attributes are public, meaning if I wanted to, I could just go and change Joe DiMaggio's first name to some other first name. Right? So public attributes would be something like this. We can have an init function, self, first name, and a salary. Right? So we can assign the first name, we can assign the salary. Those would be public attributes. Protected attributes are defined when you put one underscore under them. And so now I can write to these fields, but if somebody outside of this class tried to write directly to those fields, they'd be protected and you wouldn't be able to change them. And private attributes, so this is really more syntax, would have 2 underscores in front of the variables. Now just a little bit of a history in C++ and Java. You'd have to type out the word public, P-U-B-L-I-C, in front of the variable name, or protected in front of the variable name, or private in front of the variable name. And Python came along and said, why don't we put 1 underscore means protected, 2 underscores mean private. Okay, what are these fields, public, private, and protected? This goes back to, C++ back in the early 80s, early 1980s. Public fields are accessible from anywhere in your program or even outside of your program. So if you create an object called, if you create a baseball player, BBP, and the person's first name is Joe and the last name is DiMaggio, I could come along and say BBP.first equals Tom. And now all of a sudden he's Tom DiMaggio. If I make it protected, let me skip over protected and go to private. If I make it private, only the init function can set it, and other functions inside the class that have the ability to change it could change it. You cannot from the outside come along and say Joe DiMaggio's first name is now Tom. Can't do that, because the field is protected. So you can't write directly to it. Now, if you're going to inherit, the question is, should you be able to inherit fields that are protected? And this debate goes back about 30 years. Should you be able to inherit should you be able to inherit private fields? And the answer is sometimes. Sometimes a class will have fields that if someone came along and said, I'm going to inherit from that class and I'd like to get a copy of those fields too, sometimes the fields should be so private you can't even inherit from them. Other times they should be protected, but anyone who inherits from them should be able to get those fields inherited. So protected fields are fields that you can inherit, but are still blocked from being updated from outside actors. Okay, and then inheritance, we're just going to revisit this again. Okay, so suppose we had a class called person with a year of birth that is not available. That's the only default being set. And we had a constructor which we call __init, __. Pass in a first name, a last name, and a year of birth, then we fill in those fields. If these fields have a single dash before them, that means they are protected fields. They are protected fields. So what that means is, this method can write to those fields, because this method is inside the class. But if someone from the outside tried to change their first name, they're going to get an error saying, sorry, that field is protected, you can't change it. You must call a method, a public method that is inside the class, and that has permission to change it, but you don't have permission to change it directly. And then we'd have a class called baseball player, which inherits from person. So all the attributes and method that comes from persons get pulled in. And then we have an init function, self, right? We have a first, a last, a year of birth, a team, and a batting average. And now we can call the person's init method, pass in those fields, and we could take the team parameter and put that on _team, which means that the team variable is protected. People can't come along and just say, okay, now Joe DiMaggio plays for the Mets. You can't do that. Or change the batting average. Okay. Now we can add a field called, we could add another function called get batting average. And we could add that to a baseball player. And what it will return is the object, the self's protected field batting average. So if I want to know what Joe DiMaggio's batting average is, I can't, if I have a variable called BBP, and I set it to Joe DiMaggio, I can't just say print BBP.batting average, because it's going to say, sorry, the batting average field is protected, you can't see it. The designer of the class did not allow you to see it directly, because they put the underscore here, meaning it's protected. However, they could create a method that is not protected. There's no underscore here, so there's a method called get batting average. That's available to the public. And that method will return to you the batting average. So you cannot say, if you had a variable called BBP, baseball player, if you had and baseball player was set to Joe DiMaggio, you can't say print BBP.batting average. That's a protected field. But you can say you can say print BBP, get batting average, open paren, close paren. It will call the public method, get the batting average. The public method, which is inside the class, that has the right to read the batting average and return it to you. So what's very common, and I'm going to go over a whole big thing on just inheritance and inheriting from classes that have no attributes. Inheritance is a pretty complicated field, but it's just good for us to get a little taste now when we're talking about classes, because what we want to do is we want to recognize the fact that we can, what's pretty common but not 100% common is all your data fields, the team, the batting average, the first name, the last name, the year of birth, we typically protect our data, and then depending on what our users are going to use the data for, we supply them with public, see there's no underscore here, public methods, and say, you know, you're allowed to do this, you're allowed to do that, but you can't just run around and start changing all our data. Right? So in other words, so for example, we might have a method, we could add a method called, let's say for example, set year of, let's say we had a field called update batting average, right, update batting average. So we don't want somebody to come in and say, Joe DiMaggio's batting average is like -40. You can't have a negative batting average. In baseball, there's no such thing as a negative batting average. But considering that fields in Python are integers or floats, floats can be negative numbers. But in baseball, there's no negative batting averages. So if we made a method, a public method that's called set batting average, we could take an input parameter and we could do checks on it. We could say, well, I'm not going to take any negative numbers. I'm not going to take a batting average that's over 1,000. That's unacceptable in baseball. So we can check the data, and if it's checked out to be legitimate data, then we can set the private field, as opposed to just giving programmers the freedom to just come in and change anything. So we don't want people coming in and saying Joe DiMaggio's first name is Mickey and he plays for the Mets. We don't want that. We only want legitimate data in our fields. All right, so this is just a little bit, an introduction to the idea of classes. So what classes are is if you want to make a structure of data that's not supplied by Python, you want to supply it, you want to define it. You want to say a person has a first name, a last name, and a year of birth. And then you want to define a baseball player, which is a person. In addition to being a person, it's you have a batting average and a team that you play on. Those are your definitions. We don't expect Python to know how you want to define a baseball player. We'll make it up. So if you're going to start making up data structured data, you use classes. Classes are how you describe to Python how the data should appear. Then we don't want users of our program to come and destroy our data. So we protect our data. But they have to be able to use it somehow. They have to be able to set some fields and read the data, otherwise the application would be useless. So we protect our data, and then we supply methods, public methods, where they can read and write our storage. All right, so we'll cover more topics on inheritance, because it's pretty tricky, but also very interesting.